Welcome to the Java for Programmers course. Before we talk about the course, let's talk about myself. My name is Naveen Reddy. I'm a corporate trainer, YouTuber, a software developer, and currently focusing more on Java and blockchain. I have been working on Java from last 12 years, working on different applications and training millions of students. In fact, one of the video on YouTube, which is titled as Java for Beginners, which got around more than 4 million views. Then I thought, hey, there are a lot of people, they want to learn from beginning, right? And that's why the course makes sense. On the other hand, we have people who have been working on some other languages, let's say JavaScript, Python, C, C++, or C#. And what if they want to learn Java? Of course, most of the languages have same concepts. They have variables, arrays, string. The question is, how will you do that in Java? Instead of them watching the Java for Beginners video, what if they can learn Java in a short time? And that's where this course comes into picture. And the course name is Java for Programmers. Now in this course, I'm assuming that you know the basic concepts of programming. And the question is, how will you do that in Java? And the focus would be on different concepts. We'll start from the basic, of course. What are the things are needed as a toolkit? You need JDK there, you need an IDE. We'll talk about those things. Then we'll move towards what is Java, Java fundamentals, and we'll focus on one of the most important things of Java, which is object-oriented programming. Then we'll also see how Java works behind the scene. And then some advanced concepts. We'll talk about arrays, string, packages, access modifiers, abstract classes, interfaces, collection API, threads, and exception handling. Now, all this concept is bundled in this short course. Now, one of the questions is, what is Java and why Java? Now, first of all, let's talk about Java itself. Now, Java is a language and a technology because there are a lot of frameworks available, there are a lot of tools available. One of the important things in Java is JVM, and Java is not the only language which works on JVM. There are multiple languages. You might have heard about Scala, Kotlin, Groovy. They also run on JVM, and that's why it becomes important for us to understand Java as a technology. On the other hand, Java language is very famous. In fact, as per Oracle, which is the owner of Java language, Java runs on 3 billion devices. And they are saying this from a long time. The number might have increased. But the thing is, Java is a very popular language, especially in the enterprise market. Most of the enterprise are using Java as their main language. And if you check for the ranking of Java, it always stays in top 5, mostly on 1 or 2 or 3. But Java is there on top from a long time. And currently, every 6 months, we are getting a new version of Java. So Java is moving very fast. They are introducing new concepts every 6 months, okay? And that's why most of the companies are moving back to Java. They are using the full power of this language and the technology. Now, this will be a fast-paced course, assuming that you know other languages. And of course, I assume that you will enjoy this course and you will not get bored by watching and practicing the code. So let's start our journey with Java. Now, as a language, of course, you need an IDE, right? So you might have worked on different IDEs for different languages. In Java also, we have to use an IDE. I mean, of course, you can use Notepad as well, or you can use some advanced IDE for Java. One of it is IntelliJ IDEA. You can use Eclipse, you can use NetBeans, Edit Plus, and currently I'm working on VS Code, so that perfectly works. So in this series, we are going to work with VS Code. So that's the first thing we need. The second thing we need here is a Java compiler, and it comes in a bundle called JDK. So basically you have to install JDK, which stands for Java Development Kit. Okay, so of course, right, most of the languages are either compiled or interpreted or both. And in terms of Java, it's both. So basically you need JDK to compile your code. Basically it has a Java compiler. And when you compile your code, it gives you a file which you have to run. Of course, we'll understand that in detail later. As of now, we need JDK and we need an editor, which is your IDE. So in this case, let's download the JDK first. So you can go to Google and search for download JDK, and this is the official website for Oracle JDK, which is the proprietary version. But you can also choose an open source version if you want, but Oracle JDK works. And currently it is free, so you can use it. Few years back, Oracle made Java paid, so now it's free, so you can use it. Now, which version to choose here? So Java 17 is the LTS version, which is long-term support. So we are going to use Java 17 here, and you can just go here, you can click on download. So if you scroll down, you can choose between Java 19 and Java 17. So you can choose Java 17 here. And since I'm doing this on Mac, I will click on Mac OS. Now, depending upon which OS you're working with, if you're using Windows, you can choose that, but let's choose Mac. And let's download this part. Now, of course, you have worked with different languages, so I assume that you know how to install software. It's straightforward. Next, and your job will be done. Okay, so that's the first thing you need. The second thing you need is VS Code, and you might have used VS Code or any other IDE. Same setup, you just have to go to the website of Visual Studio, and you can get the download option here, and you can get this version. Now, once you have both the things in your machine installed, you can simply open VS Code. Of course, you will get started, but I have already worked on this tool, so just ignore that. This is the blank VS Code which you will get, and what I want to do is I want to open a particular folder. So what I've done is I have created a folder called files, and I've opened that file here. So you can see we have files here, and now you can just close this, and this is where you are going to write your code. The beauty is, most of the languages, they have an option of REPL, which means you can write one line of code. Now, if you're coming from Python or other languages, you can simply write one line of code to print hello world. A lot of people, they hate Java or they don't learn Java is because when you write the first code in Java, it's a bit complex, and that's where they feel demotivated. But don't worry, in Java 9, they have introduced something called REPL, which is JShell. So what you can do is you can open your terminal, and since we are using Java 17 here, we already have JShell installed. So if you type JShell here, it will give you a prompt, and this is where you can execute your Java statements. That's right, you don't have to write the entire file to get started. So in this, we're just going to write a simple code. Let's say I want to print something on the console. What you can do is, if you want to print something, basically whenever you work with string, we know that we use double quotes, or we use single quote in some languages. In Java, we use double quotes. Now what I want to print is, I want to print hello world, and since it is done with the help of functions or methods as we do in different languages, we have to also put that as a function or a method here. So in Java, we call them as methods, and every statement need to end with semicolon. And here what you can do is you can say the function name or the method name, which is println in this case, and it belongs to system.out. So you have to say system.out.println to print something, and when you say enter, okay, we got an error because I have just put a comma there. My bad. So let me try once again to print hello world, and if I say enter, you can see we got hello world. So basically this is how you can write a statement to print something. Let's make it more simple. What if you have a value you want to store with? Of course, right? When you build an application, you want to store values, and normally we store that in variables. So how do we create variables in Java? It's very simple. You use a variable name. Let's say variable name is num, but you also mention what type of variable you have. So you have to mention the data type. So Java is a statically typed language where before using a variable, you have to declare it with a type, of course. So the type we are using is int. Now basically we have different types available here. We have int, we have float, we have double, we have short, byte, character, boolean. So we have all these options. And as with other languages, int means you can have numbers from negative range to positive range. We have double, which supports the point values. Then we have float, which is a small size double, you can say. Then we have characters for characters. We have byte for a small int. We have short for double the memory of byte. Then we have long as well. If you have a longer integer, you can use long there. Or if you want to store true and false, it supports boolean. Okay, now this all are called primitive data type basically. So we have int num equal to, and we can specify the value. Let's say if value is 5, and we can give a semicolon, enter. So you got a variable and you have assigned the value 5 here. Now, if you want to use this variable, you can say enter, you can see the value of num is 5. So this is how you can basically create variable. Of course, you can perform operation as well as with other languages. We can say 2 plus 4 is 6. So Java is actually easy if you use JShell. But of course, right, when you are learning Java, you're not learning just to print one statement. You want to run multiple statements to build something. And that's where you will create files. Now, what I will do is I will go back to my files folder here. I know that's a weird name to have a files folder, but let's go with a folder here, which is called files. And in this, I will create a new file. I will name this file as, let's say, demo.java. So all the files in Java ends with .java extensions. I mean, when you have a Java code there. And when you say enter, this is the place where you write your code. Now there's a particular syntax we have to follow if you want to run the file as a file. I mean, if you want to run Java file. In case of JShell, you can write one statement, but when it comes to a full code, we have to write multiple lines of code. Now we have to, as I mentioned, we have to follow a syntax, which is fixed. You can't change it because internally you have something called JVM. Now, when you run the application on your JVM, JVM will look for this syntax. So you have to follow the syntax. The syntax is, everything in Java should be in a class, and it will have a same name as class name, not compulsory, but you can have, let's say, just to make it simple, we have a class name, same as file name. And then you have to use public static void main. In brackets, you have to say string, and you have to pass an array. You can see I'm passing an array here. Now, what does this mean? As we know, most of the languages starts with a starting point. So main is the starting point of execution. What if you have a project which has, let's say, 100 files? In each file, you have 100 classes, you have 100 methods, which are, let's say, imagine functions. So let's say you have 10,000 methods or functions. From where to start? So JVM will look for the main function, the main method. Syntax for main is it should return nothing, so it should be void. It should be static. Again, we'll discuss what is static keyword later. And it should have a public access so that anyone can access it. It is possible that when you run the application, you might want to pass some arguments. So from the JVM side, if you want to pass an argument, you can accept that in a string arguments as an array. So it's an array which can hold multiple values. And the type of it will be string by default. That means you can't send images and videos by default, okay? It only accepts strings. Okay, so what I will do is I will just try to print something. What I want to print. So I want to print hello world again. So you can do that with the help of system.out.println. So you can say sout. Now sout is basically a shortcut for VS Code as it changes in different languages. We can say sout tab, it works. And in this, you can print hello world. Now ignore this X here. X is given by VS Code, which simply says there's a variable X inside println, which is accepting this value. As of now, ignore. I have not written it. Even if I can't even delete that, you can see that I can't select it. But then we got this file, right? How do we compile this code? So basically what you do is you open your terminal and here you basically write two steps. So the first step is you have to compile your code. Okay, so you have to say Java C and you have to mention demo.java. This is how you compile the code. And how do we run the code? It's very simple. You say Java and you mention the class name. The class name here is demo. The file name and class name can be different. If it is different, when you're compiling it, you have to use a file name. When you're running it, you have to use a class name. And when you say enter, you got your hello world. So let's say if you want to create some variables here, if you want to store data, you can do that. So let's say we have int num, that's your variable to store numbers. You can also create double. Let's say d is equal to 9.6. So basically you can have a point values here. You also have a float. So basically double takes a bigger storage compared to float. So if you say float, it takes, so we can have any value here, let's say 8.5. The only thing is by default, the point values will have double type. Now, if you have a point which is 8.5, it is assuming Java is thinking that's a double value, but we are saving that in a float variable. In that case, you have to use F here to specify whatever data you're storing is of type float. We can also work with long. So we can say long L is equal to, now it supports a bigger number because it's a bigger size. We can also work with short, which is a shorter version of long. And in fact, yeah, we can work with short, we can work with byte. So those are the options we have. Apart from this, we can work with character. So let's say we have char C is equal to. Now in character variable, you can store only one character as with most of the languages. And in Java, to specify that's a character, we have to put it in single quote. And you can have any character here. Let's say A. So we got all this type of data we have. So all this type are called primitive data type because they define the type of your data. And all these are called variables. Okay. And now I can actually print those values. So I can just come back here and I can print, let's say num. Okay. And maybe I also want to print other variables. So what you can do is you can, if you want to have multiple data to be printed, we can say num plus d. But the thing is num is 5, d is 9.6. It will just add them. If you don't want it to add them, plus operator here behaves like a polymorphic thing. It works in a different way provided what data you're providing. So if you're providing integers or double, which is number type, it will add them. But what if you put that a string? Now, if you put a string in between and if you add d, so what you're doing is we are concatenating num, concatenated with a space, and then concatenated with a number which is 9.6. Let's see if that works. Compile, run, you can see we got 5 and 9.6. So this is basically how you can create a class, you can create a function, you can create variables, and you can work with the data. Now, apart from this, you can also create methods. Now, as of now, let's say we have only one method here, right? What I will do is I will just take this terminal on my right-hand side and minimize this Explorer. So basically what you can also do is you can add some extra methods here. As you can see in this demo, we only have one method, but we can have extra methods as well. The way you create functions in different languages, we can say public, static, void, show. That's my function name. And let's say if I do something here, if I say in show, what if I want to call this show? So from one particular function or method, you can call another method. The way you do that is by just going, you can type it anywhere, doesn't matter. And you can say show. But the execution will be in sequence, okay? So it will start the execution from here and down, down, down. It will print this thing and then it will call show. The moment you call show, the pointer moves to this particular method to execute. And that's why it will print in show. To prove my point, I will just compile and run. You can see it says 5, 9.6 because we are printing the values. And you can also see we got in show. So that's the thing we have to remember when you work with Java. So these are the important keywords you have to remember. Variables, we call them as, so we don't say functions in Java, we say methods. And by default, the execution starts with main, which is of syntax public static void main. Once we have seen a basic code in Java, we have worked with the variables as well. And then we were able to assign the values, we were able to print the values. And we have also talked about the primitive data types. In this video, let's try to work with the operators, conditional statements, and iterators. Now again, in most of the languages, we have the same thing, but let's see how do we do that in Java. So first of all, let's talk about the operators. Now let's say we have two variables here, which is num1, and let's assign some values to it. Let's say num1 is 4 and num2, this is another variable, and the value of this is 5. Or maybe let's make it 9 and 5 so that we can perform some operation. Now let's say if I want to subtract these two values, of course you can use, in fact I will do that in the system.out.println itself. And I will, or maybe I can just create a variable which is result equal to. Now with this num1 and num2, I can perform certain operation and I can print the data in the system.out.println. But what operation I want to perform? So let's say I want to add two numbers. I can simply say num1 plus num2. That perfectly works. This is how you can add two numbers. If you say minus, that is subtract two numbers. If you want to multiply, you will use asterisk, as most of the languages have the same thing. But if you want to divide two numbers, we use slash. In some languages, you have to use the word specifically, add, multiplication, but here we can use operators. We have slash here. What if you want to find the remainder? So let's say if you use slash, it will divide these two numbers, right? And so I'm just trying to show you some differences from other languages. If you run this code, you can see we got 1. We have not got 1 point something, which is, of course, right, when you divide 9 by 5, it will give you some point values. It will only focus on the quotient, not on the remainder. But what if you just want a remainder? In this case, you will use a percentage symbol. So percentage will give you the remainder. And if I compile and run, you can see we got 4. What else we can use here? These are your arithmetic operators which we have. Apart from this, what we can also do is we have something called relational operators. Now this is where you compare two things. Example, let's say if I want to compare num1 with num2. I want to check if num1 is less than num2. So in that case, what you will do is you will say less than. Okay, so we have to use the less than symbol on your keyboard. And what it will return is not integer. It will return a Boolean type. Because see, if you are comparing two numbers, of course you will get a true or false, right? So when you're comparing num1 with num2, you will get true or false. Now based on the value of num1 is 9, num2 is 5. So of course it will be false. So if I print result, it should be false. Compile and run, you can see we got false. But if you make this as greater than symbol, of course it will work. Compile and run, you can see we got true. So we have less than, greater than. In fact, you can also write less than equal to. So what if you want to check if the number is less than or equal to? So both should match. It should be either less than or it should be equal to, right? So that's what you can do. We can use less than equal to. Also, it can be done with greater than equal to if you want. So these are the options we have. In fact, you can check if the two numbers are not equal to. So I want them to not equal to one another. So you can use exclamation symbol there. So exclamation equal to means not equal to. And since they are not equal, it will give you true. Okay, so these are the options you have, which is your relational operators. Now, what if you have two checks? One, I want the n value should be greater than 0. I want it to be a positive number. And I also want this to be not equal to 2. Or maybe I want this to be greater than num2. So I want this to be greater than num2. And also, I want it to be non-zero. So I want to also check if num1 should be greater than 0. How do I check these two values? So if you have two conditions here, as you can see, we have two conditions here. And if you want to combine these two conditions, we know we have to use some logical operators, which is your and, or, and not. In Java, we don't say and or. We use double ampersand for and operation. We use double pipe for or operation. If you want to reverse the Boolean value, true to false, we can use, example, let's say if I have only one condition here. And of course, this will be true. But if you put a not here, that will be reverse. And the only thing is you have to put the entire operation in the round bracket so that it will complete its work, which is it will give you true and you're saying not. So what you will get here is false. So you can see we got false. Okay, so that's how basically you can use logical operators. So we have talked about relational operators. We have talked about logical operators. Now, what if you want to use something called if-else here? So we have a conditional statement, right? And most of the languages support if-else. How do we do that here? What's the syntax? So I want to print hi if the value of num1 is greater than num2 and hello if it is less than. So what you can do is you can use something called if, and that's the syntax we have to use, if and in round bracket. In some languages we give a space, but in Java we have to use round brackets. And inside this you can put your condition, whatever condition you have. If that's the case, if it is greater than num2, You have to open the curly brackets and then you can print something. You can say hi. We can also use else. So for else, the syntax is else itself. But if you want to check for one more condition, you will say else if, and you can say if n1 is less than equal to n2, you can print hello. But what if they are same? In that case, you can write else, and here you can print bye. Okay, so basically that's how you can use if else in Java. One more thing, as most of the languages, if you have only one statement, you can remove the curly brackets. That is optional. But again, that is only for one statement if you have in that block. Okay, that's one. In fact, Java also supports ternary operator. Let's say I want to set the value of a result based on the value of this operation. So what I can do is I can say, let's say 0 in this case. Initially it will set 0 because by default the local variables, these are local variables. So when you create a variable inside a method, that's a local variable. There's another type of variable which is called instance variable, which we'll see later. But whenever you have a local variable, assign the value by yourself. Okay. So what I can do is I can also check if the value of, based on some condition, let's say if I want to check if num1 is greater than 0, I want to assign the value to result as, let's say 5, else I want to assign the value to result is, let's say 10. Okay. And of course you can print the value here. You can come back here and you can print the value result. And it's good to put indentation or a proper formatting in Java. Of course, not compulsion like Python, but yeah, it looks good if you have an indentation. Doesn't matter which language you're working with, use indentation properly. And if I try to compile this code and run, and that's an important thing, every time you change something in your code, you have to compile the code first and then you can run, and you can see we got 5. But how do I convert this into a ternary operator? So Java does support ternary operator. What you can do is you can set result is equal to, if num1 is greater than 0, question mark, you can return 5 or you can return 10. So yes, Java does support ternary operator. So that's how basically we can use conditional statement. What if you want to use switch? So based on the value of num, maybe you want to print something. Let's say value of num1 is 1 and I want to have 3 values, 1, 2 and 3. And based on that value, I want to print in the, let's say word format. That's the common example. So of course you can do that with if else, or you can use switch here as we do in multiple languages. You can just pass the variable name. And you can use case as it is, as you do in other languages. So just to see the syntax, you can say if the case is 1, you have to give a colon. And whatever you want to do, you can print, let's say 1 here. And again, in Java also, we have to put break to stop the further execution if the case matches. And you can say case 2. In that case, you can print 2 and you can put a break. So yeah, basically we can do that. And again, for default, we use default. There's no other keyword. And most of the languages have default the same way. And you can say nothing. Okay, so you can use switch as well. Remember this thing, break is compulsory. So switch has multiple styles in Java, which came in later version, but the basic version is same in most of the languages. Okay, once we have talked about the conditional statement, let's talk about the iterators. How do we use loops here? Now in Java also we have different loops. We have a for loop, we have a while loop, and we have a do while loop, the way we have other languages. Now the syntax, if you talk about while loop, let's start with that. So you have to use while. And also you need an iterator. So in this case, what I will do is I will say int I is equal to 0. Let's start the iterator from 0. And then the same syntax which we use in most of the languages, it should be less than, let's say 5. And you have to open the curly brackets. Again, the curly brackets are optional if you have only one statement. And I can print, let's say, I want to print the value of I, that's it. So basically that's how you can use while loop here. And of course you have to iterate as well, all right? So same thing, we do have I++, I-, in Java as well, the way you have in other languages, which is increment, decrement. So that's how we use while. If you want to use do while, you can do that as well. You can put do here, and here we can put while, which is the condition, let's say I is less than 5. And the only thing is you have to put the semicolon at the end. Again, in Java, semicolon is compulsory because it does not work with indentation the way you work with other languages. So semicolon is a compulsory. Okay, that's how we use do while. Apart from this, if you want to use a for the same thing, you can use a for loop. In fact, in Java, we have different types of for. This is a normal for loop, which we are seeing now. Once we move towards arrays and collection, I will show you some more syntax for it. As of now, we can use int I. In fact, you don't have to declare I outside now. You can declare it inside. You can say I is equal to 0 and I less than 5 and I++. That's right. You can do all the thing in the same line, the way you do it in other languages. So that's the syntax for loop. I'm printing I here. Let's just see if this works. Compile and run. It works. Okay, so that's how we can use different loops in Java. Again, one more thing, as with other languages, you can put this thing outside if you want, and you can put I++ later. So even this syntax works as in the most of the languages. The only thing is you need to have 2 semicolons inside for, and the middle one should be a condition. Okay, that's how it checks. So that's about the operators, conditional statements, and iterators in Java. Now, once we have talked about Java fundamentals, it's time to move towards OOPS concept. Now, basically it is called OOP, which stands for Object-Oriented Programming. And the most important word here is object. Because see, in real world, everything is object, right? Whatever you use. Example, if I want to type something, I need a keyboard. If I want to move a cursor, I need a mouse. If I want to write something, I need a pen, right? In the same way, if you talk about this is an object, right? Now, who creates this object? Of course, the factory who manufactures this object. The thing is, if you go to a factory by saying, hey, I want a keyboard, the factory will say, okay, I will give you the keyboards. Of course, it will be manufactured in the factory, but for that, you have to provide them with a design. Now, in the programming world, especially in Java, we use classes to design something. So basically, to create the object, you need a class first. Okay, so class is a design, also called as a blueprint. And then what you get from that is an object. Now, in our case, in Java case, what is a factory here? Now, that's your JVM. Now, of course, we have a separate video on how Java works, but then we have a JVM who is responsible to give you the objects. So what you need to do is you need to give a class, and JVM will give you the object. So let's see that in the code. So what I will do is, first of all, I will design something. So what I want to design here. Now, since we're talking about keyboard, let's talk about keyboard. So let's say we have a class here, and let me just name this class as keyboard itself. So how do we get a class? You use a class keyword, and then you name a class, which is keyboard in this case. Of course, you can use any class, it doesn't matter, but it's good to have a sensible name for your class. So what you can have this in the keyboard. See, every object knows something, every object does something. Object knows something with the help of variables, the properties. An object does something with the help of methods. So we can say variables are properties and methods are your behavior. Of course, right, with this keyboard, of course, it has a physical property. You can specify the size of it. I'm not sure the size, let's say 8:2. That's the size of this keyboard. There's also a color for it, which is white. And it has number of keys, right? So there are a lot of keys on this keyboard. We don't want to count, let's say 100, just a round figure. So basically, it will have some properties, right? And also, it works, right? And that's why I'm using this keyboard. If it is not working, I will keep that on a shelf, right? Or I will repair it. So basically, this keyboard does something. If I type something, it will show or it will send the signal to the computer, hey, this key was pressed. Or maybe the another way is you can use this keyboard to hit someone. Let's go for non-violence here. So what I will do here is let's create some variables. Now, how do we create variables? We have seen that in the earlier videos. If you want to create a variable, let's say if I want to specify some property, I want to specify how many keys I have in this keyboard. I can simply say int keys. Now this will hold the keys. And then I also want to specify the color of this keyboard. So I will say string color. Cool. So we have these two things. We have the integer keys and then we have string color. Those are the two values we have or two variables we have. Now, of course, you can specify values to it. So you can have some value. And the beauty is, these are actually called instance variable. We have talked about local variables before. So basically, instance variable are actually stored with the object itself. We have not created the object yet, but we'll see that. And the local variables are stored with the methods. So they have their own stack. Of course, it will make much more sense once you start with the next video. But at this point, remember, these are called instance variable. Every object will have their own values or own space for the instance variable. Okay, now let me just define some behavior. Now, how do we define the behavior? We do that with the help of methods. We can specify the access to it. I want to say it is public. And then I also want to mention one more thing here, which is the return type. So I don't want this method to return anything. So we can say void. And the same thing we do in other languages, right? So we specify the return type there. Here, if we don't want to return, we can void. We can say void. And then I can use some method. So what methods I can use here? So when you press the keyboard, so we can have a method which is called pressed, right? Which is a method basically. And in this method, I can do something. Example, when I press a particular key, the signal should be sent to the computer, right? And the way you can do that is by printing here. I'm just trying to make it simple. So I can say signal sent, okay? A very simple method. So when you call press, it will say signal sent. Of course, you can write a complex logic here, but just to keep it simple, we are saying signal sent. We can do one more thing. We can have one more method here. As I mentioned, we can use this keyboard to hit someone, and maybe you can return the value as well if you want to specify. But let's say I don't want to specify that here, so I can say void, and the method name can be anything. I can say throw it. Okay, that's the method name I have. Of course, the method name should be sensible, so I'm using a sensible method name here, which is throw it. And here I can do a very simple thing. I can say got hit. Okay, so simple two methods, nothing fancy. We got pressed and throw it. Now what you can actually do is, can we use this keyboard? Of course not, right? This is just a design. Example, let's say if we talk about a new iPhone, let's say iPhone 15 coming up, and in the keynote if they mention, this iPhone has all these old features with new features. Of course, you can't actually use those features because you don't have that phone in your hand now. Right? So if you want to use an object, or if you want to use a class, a design, you need an object for it. So if I want to call any of this method, I need an object. How do we get the object? Now, before creating object, let me create a simple variable here. So if I say int num, and I can say num is equal to 8. So what I'm doing is I'm creating a variable called num, and the value for that num is 8 here. So in the first line, we are declaring variable. In the second line, we are initializing the variable. Now this variable num here is called a primitive variable, right? As we discussed. We can do the same thing for the object. Now how do we get the object? We can mention the object name. The way you have this num here, we got this reference variable. Yeah, that's what we call them. Reference variable. Now this object will have, let's say, we have to specify the type for it. What type of object we are creating? So we are creating a type of keyboard. The way you specify an int here, in the same way you specify keyboard, the type of the reference variable. And on the next line, I can say obj equal to. See, the object is not created yet. What we have created is just a variable, a reference variable. How do we get the object? See, to create the object, of course, JVM will create the object. You have to use a new keyword. And after new keyword, you have to say keyboard. So new keyword, and then you have to use keyboard as your class name, because that's your class name, and you have to give this round brackets. Now this is called a constructor. So we have this new keyword, and then we are saying keyboard. That's how you create the object. Now once you got the object, you can actually use those methods. You can call those methods. So I can say obj dot, I can call the method which is pressed, and I can call the method which is throw it. So of course, if you have the object, then only you can call these methods. And let's see if that works. So I will go back and I will say compile and run. You can see it works. It says signal sent and got hit. So basically when you call this method pressed and throw it, it will go there and it will call these two methods. And of course you can create multiple objects, not just one. We are creating only one object here, but we can create multiple objects. Okay, so that's one thing. So this is how you create a class. This is how you create the object in Java. And in fact, since they are instance variable, keys and colors, you can use them in any method. They're not specific to some particular method. You can use them in all the methods. And let's say I want to print color here as well. So we can say signal sent, and then we can print the color, whatever color you are using. So we have not specified the color yet. So what you can do is we can specify, hey, the color is white, and the number of keys I have here is, let's say, 100, round figure. And let's see if that works. Maybe you can also print the number of keys you have. Maybe you can just come down here, and that's right. You can access the variables outside the class as well. But if I type keys here, it will not work. You know why? Because keys is not a variable of this particular method. It is coming from the keyboard class. And in order to access them, we need to say obj.keys. So we have to use the object reference. Let's try compile and run. You can see it says signal sent white color. And we got the number of keys, which is 100. In fact, you can actually change the value here. What if in the throw it, you want to change the value of the keys? Let's say after throwing the keyboard to someone and your keyboard got damaged, now you're only left with 85 keys. So yeah, you can change the value of the variable. And that's why we call them variables, right? And if I run this code now, you can see you will get new value, which is 85. Because before printing keys, I'm calling throw it. In throw it, it will change the value, and then you will get a new value. But let's say if you want to create a variable which is actually a constant, yeah, that's right. You can create constants in Java. Now, how do we do that? You can make it final. So we don't have a const keyword here. Const keyword is there, it is reserved, but we don't use it. To create a constant, we use final keyword. And if you can see the moment I make it final, it gives you an error. It says the final field. Okay, so let's not use final. Remember, using final, you can make a variable constant. In fact, we can also talk about inheritance here. So yes, inheritance is there in Java. Now, how do we implement inheritance? Let's say I have a new class here, which is advanced keyboard. And in this advanced keyboard, I want to have all these features plus some extra features. So how do we get all these features in this advanced keyboard? You can achieve inheritance here with the help of extends keyword. That's why we use extends keyword, not colon or something. We use extends and then we say keyboard. So what we are getting is everything from this keyboard comes here. I mean, all the members which are not private here will come back here. And of course, you can create your own methods as well in this. Let's say I want to create a method. Of course, when you have an advanced keyboard, which will have a keypad, when you have Apple keypad with nums keys. So let's say that's advanced keyboard. And when you hit with that, of course, it will have hit num. So let's say if you're pressing some numbers there, hit num. And I want to say sent number. So basically when you are calling this hit num, it will say sent num. Now the thing is, using this keyboard object, I can't call hitNum because keyboard has no idea what hitNum is because there is no numpad here in this particular keyboard. But if I use advanced keyboard, and I prefer to use black color keyboards, which is, it looks good. But if you want to achieve advanced keyboard, you have to use the object or reference of advanced keyboard and object of advanced keyboard. That's how you change it. Okay, so now we are not creating object of keyboard, we are creating object of an advanced keyboard. And the beauty is you can use all the methods. You can use pressed, you can use throw it, and you can also use hitNum. Let's try with this. Compile, run, it works, right? So you can see we got sent number. So basically, yeah, we can achieve inheritance. And what about different types of inheritance? Now what we have done is we have one parent class. So yeah, this is called a parent class. This is called a child class. You can also say this is a superclass. This is a subclass. So when you have superclass, subclass here, we can also have the subclass of subclass or child of child. So we can have a parent, child, and child. So we can say keyboard, advanced keyboard, or super advanced keyboard, right? This is multi-level inheritance. What about multiple? Multiple does not work in Java. Okay, so there's no multiple inheritance in Java because there's an ambiguity issue, right? What if you have two classes and both have the same method, let's say show and show. And now from the child class object, you are trying to call show method. Which show it will call? So that's an ambiguity issue, right? To solve the ambiguity issue, Java says, okay, let's remove the concept itself. So there's no multiple inheritance in Java. So we have talked about two concepts of OOPS now, class and object. And now let's focus on the next one. Okay. Now, if you look at this constructor here, of course, we have mentioned that, right? So when you create the object, it will call the constructor, and by default, Java will give you the constructor. But what if you want to create your own constructor? So what I will do is I will just go back from, let's say we have a constructor here. So in this particular class, I can create the constructor, or at this point, what I will do is I will just delete this part and let's only talk about keyboard. So I will just delete this part as well. And we don't even have hitNum. So let's go back to keyboard. Now in this, if you can see, we have two variables, right? We have keys, which is assigned as 100, and we have color, which is assigned as white. Instead of assigning this variable here, if you just create this variable, and if you want to initialize it when the object gets created, we can do one thing. We can actually assign this value in the constructor. So normally constructors can be used to assign the values if you don't have it initially. So the way you can do that is by saying public, and you can mention the constructor name. The name of the constructor is same as your class name, and also constructor will not return anything. So you will say keyboard, and here you can assign the value. So this is the constructor, and you can say keys is equal to 100, and the color is equal to white. So basically the moment you create the object, it will assign the values to it. Okay, so that's how we use constructor here, and it will be called. Now there's one more thing we have to understand, the concept of encapsulation. Now encapsulation simply means that when you have your variables and your methods, they should be closely binded. What it means is, from the outside world, so when I say outside world for an instance variable, it is outside the class. So outside this class keyboard, no one should be directly able to access the variables, okay? So you have to make sure that your variables are private. So when you say private, it means no one can access this data from outside the class. Private variables can be used only inside the class. So I can make both the variables as private. But what if I want to assign this value later? So what if I want to set the value from the main class? So in the demo, I can't do that. Example, if I say obj.color, if I want to change the color of my keyboard, I prefer to use black keyboard than white keyboard. So if I say black, it will not work because we have made them as private. And that's what you get, error you get here. It says the field keyboard color is not visible because it's private. So how do we access them? So the only way to access your variables should be with the help of methods. So what we can do is, for every variable, you can create a method which will fetch the value. And for the same variable, you should set a method which will set the value. So what I'm saying is, create a method like public void, and you can say set keys. This will accept the integer value. I can say k, and I can say keys is equal to k. So what I'm doing is, I'm making sure that this keys can be only used with the methods. And of course, I can call it from here. I can say, oh, we have to do it for black as well. In fact, before I go with that, I have one more thing. I can actually make this variable both as keys instead of saying k. The thing is, this keys here is a local variable. This keys here is an instance variable. And if you want to mention that this is an instance variable, and you can see by default, it treats both as local variable because local variables will be given the preference. So when you say keys, it will get confused. Are you talking about the local variable or the instance variable? To mention that it's an instance variable, you will say this dot keys, So we are saying that this represents the current object. So that's how we represent the current object in Java. So whatever object you're working with, example, the object here is obj, this particular object. If you want to represent this object in this method, we have to say this. So the object which is calling this method, which is this. And now we are saying that instance variable, we can do the same thing for color. So as I mentioned, we need a setter method and a getter for each variable. So you know what you can do? When you're using an IDE, you can just right click here. In fact, I will do that after the constructor. I can just right click and say source action. And different IDEs have different settings here. And you can say, I want a getter and setter, both. So you can click on this for both the variables and click on OK. So it will generate a getter setters for you. So these are my getters and setters. So if I want to access this variable, example, if I want to set the color, so you can simply say obj.setColor and you can pass this as a value to it. So now you can access this variable indirectly through the methods. And if I want to get the keys value, what you can do is you can say obj.getKeys. So we are setting the value with the help of set method. We are getting the value with the help of get methods. Now this concept of binding your variables with methods is called encapsulation. And that's what we have done here. Now there's one more thing. When you talk about this method, let's go back to, what I will do? Time bin, let's remove this concept. We understood what is constructor and stuff. What I will do is I will just make this variable as normal variable so that we can do something with it. And also, since we have done that here, let me just remove everything here. Now see, if I can go back to my advanced keyboards, I can say class advanced keyboard here, which extends keyboard. Okay, and then we can have a different method here, right? Or if you don't want to create a method here, that's fine. You can simply say this is advanced keyboard and this is advanced keyboard. Of course, the object is of advanced keyboard, but the methods are actually called of a parent class. Now, what if you want to change this? So there's a concept of polymorphism. Basically, let's talk about that. Polymorphism means the same thing, but different behavior. Example, in Java, you can actually create the reference of a parent class and the object of a subclass or the child class. That is actually possible. So we can say super and sub. So superclass reference and subclass object. Now, which method it will be calling? Example, let's say if I create the same method inside advanced keyboard, but the method name will be same. I will say got hit hard, okay, because that's a bigger keyword, right? So if you try to override it, so what we are doing is we are overriding the method of keyboard with the method of advanced keyboard. Now you tell me which one it will call. So if I call throw it, will it print got hit hard or got hit? Now the answer is it will override. So this method overrides the method of the parent class. Now this is called method overriding. Now, if you look at this method, the method calling will be based on which object you create. So we can say obj is same, right? It's of keyboard. But what object you pass is important. Example, if I run this code, compile and run, you can say it says got hit hard. But if I change the object from advanced keyboard to keyboard, and if I compile this and run, you can say it says got hit. So which method to call is based on the object you create. That's polymorphic. So this is polymorphism. So same thing, different behavior. In fact, in polymorphism, we can add one more thing, which is not actually a part of polymorphism, but let's have it. So which is public void. I can create the same method, which is throw it. You can see we have the same method name in the same class, but if you can have different parameters here, that will work. So we have the same method, but different parameters. That is called method overloading. So when you have two methods with the same name, but different parameters, it is called method overloading. And when you have two classes, two methods with the same name, but they are into inheritance, you can see there is inheritance here. This is overriding. So this is a part of polymorphism. Okay, so we have a compile time polymorphism, runtime polymorphism. So when you have this is compile time polymorphism, because the moment you call this method, you specify which method you're going to call at compile time itself, because we are passing parameters. If you pass a parameter, this will be called. If you don't pass a parameter, this will be called. But in terms of method overriding, you're not sure till runtime which method will be called. So it is called runtime polymorphism. Now, apart from this, we have one more concept in OOPS, which is called abstraction. So you can imagine abstraction as the hiding of the working. Example, let's say if you drive a car, you don't actually focus on how car works, right? For you, you have a steering wheel, you have escalator, brake, and clutch. You basically focus only on these things. And of course, gear, if it is a manual car. So basically, you don't know how car is working under the hood. And that's abstraction. You are focused only on the tools you got. Implementation is not your concern. In the same way, in Java, you have to make sure that you design the application in such a way that as a user, you only see what are the features you get. You don't actually see how it is implemented. That is abstraction. Now, the way you can implement that is with the help of abstract class and interface, which we'll see later. Now, all this thing is a bundle called OOP in Java, object-oriented programming. Now let's understand how Java works. Now basically, if you remember, we have installed a software called JDK. Now whenever you want to develop an application as a Java developer, basically you need JDK because you have to compile the files, right? But what if you compile the files and it is ready now? Of course, you have to deploy that on your client side. Now on the client side, when you want to run your Java application, you need JVM and JRE. Basically, JRE stands for Java Runtime Environment and JVM stands for Java Virtual Machine. Now JVM is a place where you run the application. It has everything to run. But then sometime your application, or most of the time your application, needs some extra libraries. And that will be provided by JRE, which is Java Runtime Environment. And of course, as a developer, you need to install JDK. So basically, when you install JDK, you get this layer. So we got JDK, inside that we have JRE, inside that we have JVM. Now let's focus only on JVM here. Now inside this JVM, we have multiple areas or multiple working stuff. The first thing and the most important thing here is a heap memory. Now this is a memory where you create the objects. So all the objects will be there in the JVM. And whenever you create a method or when you call a method, for every method, it will create a stack. Now, if you remember, we have talked about local variables, right? Now, local variables actually goes into stack. Now, if you observe this particular method here, which is main, if I create a variable called, let's say num here, and num is equal to 9, now what happens is this main method will have its own stack, okay? And then in that, you will be having num, and the value for that num is 9. But what happens when you create the object? For this explanation, I can write this in one line. So if you do that in one line, what happens is this is your variable, okay? This is your reference variable. This is your primitive variable, okay? Because Java knows all the type here. But if we talk about this obj, it's of type keyboard, which you have created. Now this obj also goes into stack, but the question is, what's the value? Now let's focus on this particular line here. This is something which actually creates the object. Every time you say new and the constructor, it will create an object in the heap memory, something like this. Now this object will have an address. That address will be stored in the stack as a value for this obj. So every time you want to call a method or the variable of this keyboard object, you basically refer that with the help of obj. So when you say obj.pressed, you're basically accessing this variable to handle the object. Okay, now that makes sense, right? But what if you create multiple objects? So let's say I am just copying this line. I'm just trying to reuse the code. And then if I say obj1, now tell me what happens. Now with this line, what we are doing is we are creating another variable, a local variable inside your main stack. And in this, you will be having a new keyboard object. So of course, a new keyboard object will be created with a new address, and that will be assigned to obj1. As simple as that. So the number of objects you create basically gets created in the heap memory, and you can create any number of objects. And that's why if you can see the heap memory shape is quite expandable, but the stack will be fixed, right? So you'll be having a fixed stack size, a fixed shape stack, not the size. Okay, now coming back to, let's say, throw it. So let's say if I call this method, which is throw it here, and in this throw it, let's say you have some variables. Now, if I say int age or throw it int angle, so let's say you're throwing with an angle here. So when you say int angle is equal to, let's say, 75 degree. Now in this case, what you're doing is you're creating a local variable, right? Now where this will be created? In the same stack of main? No. Every method will have its own stack. And you can see we have int angle 75. It will be having a different stack. So throw it will be a different stack. It will have a variable which is angle, and the value will be 75. So as I mentioned before, every object will have its own memory for the instance variable. Example, if we talk about keys and colors, every object here will have its own memory for the keys and colors. So example, if I specify the keys for the first keyboard, so let's say obj keyboard is 100, and if you specify the obj1 keys, you have 105, there are two different objects with two different values. But sometimes, you want to share the same data with multiple keyboards. Example, I want to create one more thing here, which is called string brand. Of course, we are talking about the Apple keyboards here. So brand is Apple, right? So I want this to be same for all the keyboards. Let's say in future, if Naveen or Telesco buys Apple, just an example, in that case, the brand will change to Telesco and it will be applicable for all the objects. So instead of storing the brand in every object, what if you make it static? Now, when you make it static, it means it will be accessible for all the objects. So instead of having that brand inside the keyboard, every object, we can just take it out somewhere in the other type of memory where you'll be having static variables. Now, the beauty is, since this variable is not linked to an object, you can call this variable with the help of keyboard directly. Example, if I want to access keys, I need object. I can't simply use keys with a class name. Example, if I say keyboard dot keys, it will not work. Okay. But if you want to access the brand, we can directly use a class name. So I can directly print this here. So the idea is you can access the static variables with the help of class name. So it also means if you have a static method, you don't need object. And that's how Java works. If you want to access static variables or static methods, you directly use with a class name. And that's why the main method is static. Because if you don't make it static, that means if you want to call main, you need to create object of demo, because without object, you cannot call a non-static method. But we all know that the main is the starting point of execution. If you don't have the object, how will you call main? And if you don't call main, how will you create the object? So there's a deadlock, right? So let's make this static so that you can call it without the object. And that's why we have static here. So certain points to remember here. Every time you use new keyword, it will create a new object for you. And every instance variable will have a copy in the heap memory. But if we talk about the local variables, it goes into stack. And if we talk about static variables, they are not stored in the heap memory or in the objects. It will have a separate memory to it. And every object will have the same value for the brand. And you can basically change the value with the help of the class name itself. Now there's one more thing. If we talk about JVM, how it works exactly is when you compile the code, that's what we are doing, right? The first step you do is you compile the files, right? So when you say compile, what happens is it will look at the Java file demo and it will try to compile the file. Every time you compile a Java file, it will create a class files. How many class files? Based on how many classes you have. Here, if you can see, we have class keyboard, we have class advanced keyboard, and we have a class demo. And that's why if you see File Explorer, we have advanced keyboard.class, we have demo.class, and then we have keyboard.class. So every class will have its own class files. And when you run the code, these class files actually run on your JVM. Now these class files are also called as bytecode. So what you create is a Java file. This Java file goes into compiler and you get a bytecode which goes into JVM to run. This is what makes Java a platform independent language, is because everywhere you have JVM, you can run this bytecode. It's not dependent on a machine. Because when you compile the code, you get a bytecode, right? And you can run bytecode on any JVM. The only thing is your machine should have JVM. So if you have a machine or an OS which does not support JVM, you cannot run Java. So when it comes to Java as a platform independent language, it's actually JVM should be there. Okay, so that's, whenever you read good thing and you see a star there, that star it is, terms and conditions apply. You need to have JVM to make it work. And that's why, since you can write this code once and you can run it anywhere without compiling, that's what makes Java a Vora language. Write once, run anywhere. In this video, we'll talk about string and arrays. Now let's start with string here. So whenever you have a word, a text, so normally you store that in a string. So we can do that with this. So we can say string s is equal to, and we can store the value, which is, let's say, Naveen. The thing is, string is a class in Java. So it's not a primitive type. Basically, it's a class. And what you're doing here is creating an object. Now you'll be saying, we can create object with the help of new keyword, right? That's right. Actually, string, how it works is we can say new string. This is how you create a string object. And in the constructor here, you can pass the value. Now the thing is, since string is so important in Java, so they made it simple. Instead of using new string here, you can actually write Naveen, and that also works because behind the scene, it will create object for you. Now, one thing to remember in Java, that string are immutable, which means if you say s equal to s plus, let's say, Reddy here, if you're thinking the same Naveen has changed to Naveen Reddy, that's not the case. Let me just print that and let's see if it works. And compile and run. You can see we got Naveen Reddy, but the same Naveen is not changed. It's immutable. So what happens is in JVM, there's a special memory called string pool. So whenever you create a string like Naveen, it gets stored in a string pool. And this S is referring to that string pool. Now, when you change a value, it is not changing the existing Naveen. It will create a new variable or new string literal called Naveen Reddy. Naveen is still there. Okay. And one of the beauties, if you create a new variable, let's say S1 is equal to Naveen, we are not creating a new object here. Both S and S1 are referring to the same Naveen in the string pool. Okay, so there is one thing to remember in Java, which is string are immutable. If you want to make it mutable, if you want to change data, we can use something called string buffer. So using string buffer, if you use that class, you can actually change data. So we can basically say here, instead of using string, we can say string buffer as. The only thing is you can't use shortcut here. We have to say string buffer. And in this bracket, you can say Naveen. Now with this Naveen, actually you can change the data. Example, if I go back, I have to say s dot because it has some methods to change data. You can say append, and I'm appending this with Reddy. So what we are doing is we are actually changing Naveen to Naveen Reddy. So this is how you make it mutable. So strings are by default immutable, but you can make it mutable as well. And if you use a normal string here, example, if you say string s is equal to Naveen, it has a lot of methods to it. Example, if you say s dot, it has one of the method which is length. It will give you the length of the string. You can also get a particular character for an index. So what is index basically? So this Naveen has a index number. So n is at 0, a is at 1, v is at 2, and list goes on. So basically index number in Java starts with 0. In fact, in most of the languages, it starts with 0. So that's how it works. So you can get the character as well. Now, since we talked about string, let's move towards a concept of array. So let's say we have a number here. Of course, when you have an int variable num, you can only have one value here. What if you want to have multiple values? What if I want to create a nums which can hold multiple values like 6, 7, let's say 1. So we got 8, 6, 7, 1. We have 4 values here, right? Of course, if you want to store this, we have to get 4 variables, maybe num1, num2, num3, num4. Or you can create a box which will hold all these values. And that is what called is an array. And if you see, we have array as well. As we have in most of the languages, this is a concept of array. And the way you can do it in Java is you can put that in curly brackets. This is how the int array looks like. But if you want to create an array without the values, you can say new int, and you can specify the size here. So when you say 5, the size of this array is 5, and then you can manually assign the values as we do in most of the languages. Let's say we can say 8, and then we can say nums of 1 is equal to 2, and list goes on. So let's do that quickly. In fact, instead of assigning values here, I can give some static values, because if you know the values, you can directly assign the values here. Let's say 6, 8, 3, 2. And if you want to print this value, we can use normal for loop as well. Of course, you can print one by one, but if you want to print all the values, you can say int. You can use a loop. The loop starts with 0 because index value starts with 0. And I can say less than. Instead of saying 4, I can say nums.length. It's a property in array. And I can say I++. And here basically, I can print the value of nums of, instead of saying 0, 1, 2, I can say I, because the I values keep changing, right? So it will say nums of 0 is 6, nums of 1 is 8, and it will print all the values. Let's see if that works. Compile and run. You can see we got all the values here. Now this is a normal for loop. Now with array, basically we can use an enhanced for loop. Let me comment that section. I will say for int I is, so we can say int, instead of I, we can say num, or we can say n, and the value for n is coming from nums. This is called an enhanced for loop. Now what we are doing is we are not actually working with index value. How it works is, this nums has 4 values, right? This loop will run for 4 times, and each time the value from nums will be coming to n. Initially the value of n would be 6, then it will be 8, then it will be 3 and 2. And whatever value you have in n, I can simply print it. This is enhanced for loop, much better than this for loop here. There's one more problem with this normal for loop is we have to work with length. And sometime, when you do fast coding, sometime you put equal to there, it will give you an error. Okay, because if you try to access the element outside the array, it will give you an exception called array index out of bound exception. So to ignore that, enhanced for loop actually makes sense. So if I compile this and run, it perfectly works. Now the beauty is in Java, it's not just about creating the array of primitive values. You can create array of any of your class. So let's say if I create a class here called maybe student, I can create multiple student array. So let's say int roll number, and then we have string name, and let's also have a constructor for this. I will say right click and say source action. We can get the constructor with both the values, so that when I create the object, I can just pass these 2 values there. That's right, you can have a constructor which takes multiple values. And also I want to print the object of student as well. The problem is if I create the object of student, if I say student s equal to new student, and of course I can pass values, let's say roll number 4 and name is Naveen here. And if I try to print object of student, it will print something which will difficult to understand. Compile and run. You can see it is printing this weird thing, okay? Now the beauty is, it is printing this is because every class in Java extends an object class. So object is a special class in Java, and by default, every class extends the object class. And in this class, there's a special method called toString. So every time you try to print an object, it will call the toString method of object. Let me show you that. So if I say s dot toString, and if I go to definition of toString, you can see toString method belongs to object class, and what it does is it prints the class name and it prints it prints the hash code in the hexa format, and that's what you can see here. We got the student with the class name @ and we got the address. We don't want this. What you can also do is you can actually override the method. We have seen that in polymorphism, right? We can right click and we can say, I want to override the toString. Instead of calling the toString of object, I'm calling a toString of student. So now when I try to call this, if I try to compile and run, you can see we are printing the value, okay? And one more thing, the toString here is not compulsory. The moment you try to print the object, it will call the toString by default. Okay, now one more thing. I don't want to create one object. I want to create multiple objects. What you can do is you can create the array of student. I can say students is equal to new. I want to create the array of students. So I can say student. But instead of creating the object, I can create the array of 4 student references. Okay. Now, mind you, this students is not the array of, in fact, this is an array. So I have to say array here. This is how basically you can create an array of references, object references. This is not array of objects, okay? And if you try to work with this, this will give you null because all the values are null here by default. So what you have to do is you have to say student of 0. This is my first student object. I can create like 2 more. So basically here, instead of saying 4, I can say 3. And I can say this is 1, this is 2, roll number 5 and 6. And name, let's say Harsh and Kiran. Now, if you want to print this 4 objects, we can also use the enhanced for loop here. The type of student is student. So we have the type is student. We can say S, and this is coming from students, right? And basically what happens is every student reference here. So in total, we got 3 references, right? One by one, it will be assigned to S, and you can basically print S. So yes, we can create the array of student here, compile and run. It works. So the idea is, so we can create the array not just of primitive values, but also of the object type. So we got a student class here, and we all know by default every class extends object, so we don't have to mention that. And if you want to print the details of a particular object, which has instance variable, you can use toString to print it. And of course, you can change this string the way you want. And basically you can create a student array. This is the array of the references, not the object. For every reference, you have to create the object by yourself. If you don't do that, it will give you error. That's a point to remember. In this video, we'll talk about packages and access modifiers. Now let's talk about packages first. See, the thing is, when you build an application, of course, in your project, you'll be having multiple Java files. And most of the time, we write only one class per file. In the earlier code, we have written multiple classes in the same file. But ideally, when you build a project, you'll be having one class in a file. And of course, you'll be having multiple files, right? Now let's only talk about classes here. The thing is, when you compile your code, you get a class file, right? So depending upon how many classes you have, you will get those number of class files. And of course, let's say in your project, you have 100 classes. What you will do is you will get 100 .class files and you will put that in one folder. Now, how do you give this project to your client? How do you deploy that on your server? So what you do is you do a packaging of it. A packaging can be a jar file, a packaging can be a var. Now, if you're coming from .NET world, we know there's a concept of .exe, right? So on Windows, whenever you install the application, you see a .exe there. And for Linux also, we have different extensions for the package, right? Now in Java, we do jar and var. But the thing is, in this jar file, will you put all the classes as a one folder? That's not a good case, right? Because if you want to search for it, it will be difficult for search. And also, sometimes you want to create a library so that other people can use it. It's not for executable, but maybe someone else is building a project and you want to give your project as a library. So what you do is, so instead of storing all the classes in one folder, what you can do is you can create multiple folders depending upon their uses. Example, let's say there are few classes which connects to database. You can put them in a DB folder. You have few classes which are utility classes. You can put that in a util folder. There are some classes which are interacting with a user, maybe controllers. You can put them in a controller package or a folder. Every folder here is called a package. And the beauty is you can have a folder inside a folder, that is package inside a package, right? So let's say we have a class called a DB connection, and this DB connection class or the file belongs to a DB folder. Now this DB folder belongs to your project name, which is, let's say, demo. And this demo project which you're building belongs to a company called telesco.com, right? or telesco. So what I can do is I can have a unique package name for a particular class. So I can say com.telesco.demo.db.db connection. The advantage for this would be I'm making sure my library is unique throughout the world. You know how? Because I own telesco.com. So you can just reverse your domain name and you can have that library. Okay, so basically how do we create packages here? So let's imagine in our project here, we have multiple classes. As you can see, we only have one file here, but let me create a.java. A.java will have a class called a class, and we got b.java, we got c.java. What you can do is you can put this thing in a particular package. Example, I can put demo in the main package itself, and I can put them in some other packages. How do I do that? To create a package, you have to use a keyword called package, and then you can give a package name. So let's say com.telesco, that's my package name, and how it looks like behind the scene in a system explorer. So it will look like a com folder. Inside the com folder, we have a telesco folder. Inside that, we have a demo folder, right? And then we can say our app. Okay, that's the hierarchy which I'm creating. And of course, we don't have this here. So what I can do is I can just click here and I can say move a.java, which is openly available, to this package. The moment I do that, can you see that? We got that hierarchy here. In fact, you can just open this in the Finder or your System Explorer. And if you observe, we have com. Inside that, we have telesco. Inside that, we have demo. Inside that, we have app. Inside that, we have A. Of course, you can have B in some other packages. So I can just go back here. Maybe I can just reuse my code. And I can put this in something else. I can say com.telesco.demo. Now let's say B is connecting with a database. So I can say demo.db. So now it will belong to a different package. As you can see, they are in two different packages. A belongs to app, B belongs to db. And of course, you can put C in some other folder, or maybe in the same folder of A, even that works. So let's put that in the same package of A. And you can see now A and C belongs to the same package. So it's always a good idea to save that in this package structure. One thing to remember, you have to put your packages on top of here. Now, one more thing. What if I want to create object of let's say C in demo? How do I do that? Example, let's say, if I simply say C obj equal to new C, this will not work because it says I'm not able to find C. And that's what we have to do is you have to import the package because demo is in different package, right? So how do we do that? So we have to use a keyword called import and we have to mention where C belongs. So C belongs to com.telesco.demo.app.c. That's how you import something. What if you want to have A as well? Of course, you have to write the same thing, but this time you have to say A instead of C. We are importing two things here. But what if you want to import everything from app folder? You can also say star. Again, when you say star, it means you are importing everything from app, not from com or telesco from demo, only from the app. Okay, and that's why it works. So you can see now I can create the object, there's no problem. So packaging is a good thing. Always create packages when you create a project. Yes, for learning purpose, we were not doing that before, but when you're building a project, it is important. Now after this, let's talk about access modifiers. Now what are modifiers? Example, if you talk about this public, this is access modifier, right? When you talk about final, that's also access modifier. What we can do here is, let's say we have class B here. Let me just minimize this part. And let's say we have class A and B, they are in two different packages, right? What I will do is I will make B as a subclass of A, first of all. Okay, it is not able to find A. What's the solution for this? Of course, you have to import the package. You can also take help of your IDE. You can say quick fix, import, and done. Importing done here. You can see now there is no problem. That's how you import. The only thing is package should be the first line, and then you can write the other codes. Import will be the second one then. If I go back to A, let's say if I create a variable called A here, okay, very simple variable A, or maybe just to simplify this, let's say num, so that you will not get confused between A and A again. So let's say we have num. And now, let's say if I go back to demo, instead of creating object of C, let me create object of A. So what do you think? Can I access num variable here? So if I say obj.num, you can see it is not working. You know why it is not working? It's because the A class is in some other package and the modifier for this is not public. If you make it public, there's no problem. You can see it is working. So basically, whenever you make a member public, that means it can be accessed from anywhere. Any package doesn't matter. But if you don't mention public, it gets a default access modifier, which is accessible only in the same package. Example, in the app, we have B as well, right? Or we have C. You can actually access the num in the same package. This variable can be accessed in the same package. Example, let's say in C, if I create object of A, and if I try to access num, it will work. because it's in the same package. How about B? Can I access num inside B? Let's try. So I'll say public void show, and let me try to print num here. And you can see it is not working. Of course, we don't have to get object of A because we are inheriting it, right? So whatever belongs to your parent belongs to you. I should be able to use num, but I'm not able to do that. Again, if I make this public, then there will not be any issue. You can see there's no issue. But the problem is if I make it public, it will be accessed from anywhere. What I want to do is, I want this particular variable to be accessed only by the subclasses or in the same package. What if someone is trying to access num, which is not in the same package and not even a subclass? I don't want to provide the access. In that case, you can use protected. So protected means it can be accessed by the subclass irrespective of the package. If you go back to B, now there's no problem. So protected modifier helps your variable to be accessed in the same class, in the same package, and in the subclass. Okay, so basically with this, we have 4 modifiers. We have already talked about private, remember? Private members can be accessed in the same class. Protected can be accessed in the same class, in the same package, and in the subclass of other packages. Default will be accessible in the same package, in the same class, in the same package. And we have public, which can be accessed from anywhere. Now, apart from this, we have final as well. Now, if you remember, we have talked about final when you want to make a constant, but we can also use final for the methods. Example, let's say, if I create a method which is public void show, right? And in B as well, we have the same method. So overriding is possible here. But what if instead of, with this public, you also mention final here. The moment you make it final, you can see it will give you error. So basically, whenever you want to stop overriding, we can use final methods. So final method stops overriding. We can also make class final. So I can say public final class A. When you make a class final, it will stop the inheritance. You can see that we got another here. It says the type B cannot be a subclass of final class A. So just to reiterate, final can be used with a variable, which makes it constant. Final can be used with a method, which will make it non-overridable. We can use final with a class, which will make sure that your class cannot be inherited. Okay, so those are the modifiers we have seen: public, private, protected, and default. Those are normally access modifiers. And apart from this, we have final as well. In this video, we'll talk about abstract class and interfaces. Now, first of all, before we even talk about abstract class and interface, let's take a small example. Let's say I want a computer class here, or maybe let's say I want a laptop class here, and what laptop needs, we'll discuss that later. Say as a programmer, of course, normally I call programmers as aliens because we live in a virtual world. So let's say we have an alien here, and as a programmer, what is your job? In fact, just to make your work easy, let's say this is a developer. So let me got dev. And as a developer, what you do, you write code, right? So example, if I say public void code, right? Of course, that's what you do, right? You make applications. And to make an application, you can simply type here coding or writing code or building application. The thing is, if you want to write code, of course, you will not do that on a paper, right? You will not take pen and paper to do it. Of course, sometime to understand the concept, you do that, you draw everything on the paper. But if you want to make it work, you have to write a code on the IDE. So basically, we have to code, right? And for that, we need a laptop. So of course, as you can see, I have a laptop class here. So basically, if someone hires you by saying, hey, developer, you have to work, you will say, okay, you give me a laptop, I will work. So basically, if someone hires this developer, let's say developer 1, or maybe we can say dev 1 is equal to dev. So we got a developer here. But if you ask, hey, developer, you need to code, your developer will say, okay, I will code provided you give me a laptop. So that's why you can actually pass the laptop object. And that's what you do, right? When you get hired by companies, they will give you a laptop to work on. And then using this laptop, you can work. But what exactly laptop does? So of course, in this laptop, you have to install some softwares to code. So I will say I am installing a compiler, which will compile the code. And it will simply print compiling. Okay, I'm just trying to make it simple. That's why simple examples. So compiling, okay. So after saying coding, we can say lap dot. You will call this method called compile. Of course, on your laptop, you will be having some softwares using which you can compile the code. And that's what we are doing here, right on the right-hand side when we say Java C in the file name. So what we are doing is we are trying to call this compiler method from this method which is code, which is available in dev, provided you have a laptop object. So if anyone wants to call code, so if the company says, hey developer, code, you will say, first give me a laptop object. So company has to, before they hire you, they need to first get a laptop, right? So they have to buy a laptop. So let's say they are buying lap is equal to new laptop. So they are getting the new laptop from the market. And then they can simply pass this laptop. So whatever laptop they have bought, of course, if they have 5 developers, we need 5 laptops. But at this point, we only have 1 developer and 1 laptop. That perfectly works. You can say there's no issue. Now let's check if this works before we continue. So I will say Java C, and I will say, okay, file name is demo.java, and let's run this file. And you can see we got the output. It says coding and then compiling, because that's what we're doing here. Now we can do one more thing, which is it compulsory for the company to give you a laptop? What if a company says, hey, I will give you a desktop? It is possible because in this world, we don't just have a laptop, we also have a desktop. And as per my experience with desktop, it works faster and it's better for upgrading. So let's say we have desktop as well, which has a compiler, and it says compiling faster because desktop works faster normally with the same configuration. Okay, so what if company says, hey, I don't have a laptop with me. What I have is a desktop. So let's say company says we got a lot of desktops. You'll say new desktop. And now if I ask you to code, developer, we will not give you a laptop, we'll give you a desktop. But then you cannot work. You can say, hey, I only need laptop, because in your implementation as a developer, when you say you are coding, you need a laptop. Can you make this as a compulsion? Of course not, right? This is not a good way. So how do we solve this problem? I want this developer to handle both laptop and desktop. So whatever company gives you. So in that case, what you can do is you can use a concept of abstraction. You can create a upper layer. So instead of saying they are laptop or desktop, you can create a class called computer, because both are computer, right? So both are computer and both have this method which is public void compiler. But at this point, I don't know how to implement compiler. So as a computer, it's just a concept, right? And every compiler, every machine has a different implementation. At this point, I don't know how to write this code. But then what I can do is I can make this desktop extends a computer, and this laptop also extends a computer. Now, can we say that desktop and laptop both are computers? They are, right? So instead of creating a reference of a desktop, can I create a reference of computer? We can, right? So desk 1 is referred as a computer, but originally that's a desktop. Example, if you look at this mobile phone, I can say this is a mobile phone object, but I can refer that as a computer. In the same way here we are doing computer, desk 1 is equal to new desktop. And now I can actually pass desk 1. But the only thing is, as a developer, you need to have in your mind, hey, if I want to code, there should not be a compulsion of laptop or desktop. It should be computer. If you make it computer, then doesn't matter what object they pass. If they are passing laptop object, it will work. If they pass desktop object, it will work. So what we are doing is we are trying to create an abstraction layer. So we got a layer which is of computer, which is providing a design for a laptop and a desktop. So when you say, if you take anything with you, example, if I take this car key, can I say that's a computer? No, because this car key is not extending computer. Right? So that's one thing you have to remember. Okay, so this is how you basically solve this problem. So it doesn't matter now if you pass a laptop object or a desktop object, it will work. The only thing is, based on what object you pass, it will call that particular method. It says compiling faster is because we are creating desktop object here. We're passing desktop object. But what if you pass the laptop object? So I will just uncomment this and say this is a computer also. I mean, this is a computer now. Even if its name is lap, it's a computer. And I can pass a lap here. So there's no compile time issue. Run, it is working. Can you see that? So if you try to understand this concept more, what we are doing is we are creating a class which has no meaning. The problem is, with this class computer is anyone can create an object of computer. If I can come back here, I can say computer com is equal to new computer. We can do that. But we don't want it, right? We don't want computer object. It's just a concept. So what we can do is we can name this type of classes as abstract, and we can make this type of methods, which is not doing anything, as abstract. And instead of defining them, because anyway, we have not written any code there, right? It was empty. So we can declare it. So using this abstract keyword, we can make the method declared, and we can make a class abstract. Now the thing is, if you have a method in the class which is abstract, the class should be abstract. Okay. And second, if you have a class abstract, there is no compulsion that you should have abstract method. Example, you can have an abstract class which can have normal methods. Okay. There is no issue with that. So even this works. So a class, abstract class can have abstract methods. Abstract class can have normal methods also. But the thing is, when you talk about abstract class, you cannot create object of abstract class. If I try to create object of computer here, now you can see it will give you an error. So you can see we got an error here. It says cannot instantiate the type computer. Okay, because computer is of type abstract. So point to remember, abstract class can only have the declarations and definitions, but then you can't instantiate it. Any class which is extending an abstract class need to implement the method which is compiler. If you fail, let's say if I comment this section, you can see you got an error. It says the type desktop must implement the inherited abstract method compiler. If you don't do that, in order to make it work, you have to make this class as abstract. So this class also becomes abstract. And now when desktop becomes abstract, you can't create object of it. It's always a way where if you don't want an abstract class, make sure that you implement the method. Only the abstract methods. If you have normal methods here, which are defined, there is no compulsion to implement them. Only the abstract methods. Okay. Now, there is one more thing. If you have an abstract class which only has abstract methods, so instead of using abstract class, we can do one more thing. So we can make this as an interface. Now, how do you differentiate between abstract class and interface is in abstract class, you can have normal methods. In interface, you can only have methods which are declared. So all the methods in abstract class, by default, they are public and abstract. You don't even have to mention it. So everything in the interface will be by default public abstract. You don't have to put those two keywords. And now if you talk about a class, now computer is not a class, right? That's an interface. So you cannot say extends. What you have to say is, we have to use a different keyword, which is implements. So here as well, it is implements. Again, you cannot create object of abstract class in the same way you cannot create object of interfaces. But yes, you can declare it. You can say this laptop is, or this lab reference is of type computer because that's an interface. You can create a reference of interface, but the object should be of a class which implements it. Okay. You can do actually one more thing with the interface, which is not possible with the abstract class. You can implement multiple interfaces. Example, let's say I have an interface which is movable here, right? And I can say the method name is public void move. Now, if you look at this desktop, normally desktops are not movable, right? You can't, it's not portable. Instead of saying movable, I should say portable. So we have one more interface which is portable here, and a laptop is actually portable. So what you can do is you can say portable. So we have laptop which is implementing a computer and portable both. So basically you can implement multiple interfaces, not like classes where you can restriction of one class only. The only thing is you need to define the method which is public void move. You have to define this method, otherwise it will give you error. And you can say moving. So basically this is how you implement multiple interfaces. Okay. So yeah, so that's the idea about abstract class and interfaces. In interface, you can create variables as well. Example, if I say int age or maybe int price of this computer. So we can create the variable. The only thing is by default, every variable is final. So you have to mention the price as well. So let's say $3,000. I know that's costly, but let's say the price. So we have the price of int price $3,000 for this computer. So we can create variables as well, but they are by default final. But how do I access this variable which is price? So what you can do is with the help of the interface name itself, like computer, I can say computer.price and I can print this, right? Let's compile this and run, it works. So by default, every variable in the interface, they are final and static as well because we are using computer name directly. Yeah, that's about variables, that's about methods. In fact, in Java 8, we got some new features. We can actually define the method. They made it available in Java 8 version. So what you can do is if you want to define a method like show here or maybe config, what you can do is you just have to put a default keyword. So this is something new which they have introduced in Java 8. But yeah, so this is how you can do it. Otherwise, if you don't mention default, you can say it will give you error. It says abstract methods do not specify a body because by default, every method is abstract, but you can create default methods. So yeah, that's about abstract class and interface in Java. In this video, we'll talk about exception handling. Before we talk about exception handling, we have to understand one concept, which is errors. Now, of course, right, error simply means it's not working or it's not working the way you wanted it to work or it worked, but now it's not working, right? So basically you can divide into three parts. As I mentioned, the first one is compile time errors, which is there's something wrong with the syntax or something wrong with the way you have written the code. So it will give you a compile time error. At name suggests it is compile time, right? So you will get the error at compile time itself, which is much better to handle because at the compile time itself, it will show you everything, right? What went wrong, and especially in Java, it shows you the exact error to solve. Next type of errors we can talk about is logical errors. So let's say your application is working, but the output which you are getting is not the output which you wanted. Example, let's say if you want to add two numbers, let's say 2 plus 3, it should give you 5, right? But what if you get 9? Now that's where something went wrong. So the logic which you have written is not correct. That's logical error. We normally call them as bugs. On the other hand, we have the third one, which is runtime errors. Runtime errors simply means that your code is working now, but due to some issues, it stopped working. And that's what, when you get the error, a runtime error, it will stop the execution. It can be because of the file is missing now. It was working before because the file was there. And now in the morning you deleted the file. And since the file is not there, you will get an exception and your program will stop executing. Next could be you are trying to divide two numbers and the denominator is 0. Of course, that will generate an exception. And the problem with exception is it will stop the execution of the code. We don't want it, right? So you have to handle the exception. How will you do that? Now, to understand that, we can divide every statement which you write. It can be creating a variable, doing some operation. So every statement can be divided into two parts. One, a normal statement, which is okay. I mean, we know that this statement will not create any issue. Example, when you create a variable int I is equal to 9, now we know it's a normal statement, right? There will not be any issue with this. So that's a normal statement. But what if you perform some operation like division? You're saying int result is equal to I divided by j. And we are not sure what's the value of j here. It can be 0 as well. So we have to handle the second part, which is the critical statements. So what I will do here is, let's create a simple variable, which is int I. In fact, let's create two variables, int j, and then the value for I and j, let's assign some values. Let's say 4 and j is, let's say 2. And of course, if I create a third variable, which is I divided by j. So if you look at this particular code, these two statements look normal, right? Even this statement looks normal. What about this statement? This is critical because you are performing an operation here. So what you can do is you can divide into two steps first. Let's declare the variable outside and let's say result so that we'll know what is happening. And then if I execute this code, if I say compile and run, you can see we are getting 2. But the problem is, okay, let me just do one more thing before we run this code. I want to print by at the end so that we'll know something is happening. Compile and run, you can see we got by. But what if the value of j is 0? Now what it will do is, at this point, there will be an exception. You can see we got an exception. That's a runtime error. What it will do is it will print the message as well. What went wrong? You are dividing the number by 0, which is not allowed. And then it will stop the execution at this point. That means the further two statements will not work. Okay, so we have to handle the exception here. So how do we handle? We can use a try catch block and we can put this in here and we can say catch. So whatever statements which are critical, put that in a try block. And if that statement throws an exception, you have to handle that here. So you have to catch the exception. So basically in the try block, it will throw the exception object. In the catch, you can accept the exception object or you can catch it, right? And then once you catch it, you can print something went wrong, right? And then let's initialize the result to 0, some initial value. Okay, so you can see we are trying to handle the exception here. Now, if I do that, if I compile this code and run, you can see it is printing something went wrong and it's also printing by. That means because of the critical problem here, it is not stopping the execution. So this is one case where you have to handle the exception. Second case would be, let's say you have an array of 4 elements and then you're trying to access the 5th element, which is not there. It will throw you array index out of bound exception. Example, let's say if I create an array of nums and the values are, let's say 2, 3, 4. Let's say we have 3 values. And here, let's say the value of j is not 0, it's 2. And here if I try to print nums of 4, which is not there, right? We only have 3 elements. So 0, 1, 2, that's the index number. We're trying to access the 5th element here. We don't have a 5th element. So it will give you another type of exception or the error. And if I compile this code and run, okay, it's printing something went wrong because we are doing this in the try block. But what if I do this outside? It will stop the execution because that's also a critical statement. You can see, since we are doing a critical statement outside, it is giving you an error which is array index out of bounds exception. This is what we have discussed when we were talking about arrays, remember? And yeah, so we have to make sure that we also put this in the try block. But there's one more thing. These two statements generate different type of exceptions. Array generates array index out of bound exception. This operation returns arithmetic exception. So what you can do is, in fact, you can be very specific with the catch block. You can say arithmetic exception, and you can write one more catch block here. So you can just copy this code and paste it here. And here you can say array index out of bounds exception. So what we are doing is, for different type of exception, we have different catch block here. So depend upon which statement here gives the exception first, it will throw the exception and it will try to match. Is it matching with this? Is it matching with this? And whatever matches, you can do certain operations here to handle that. At this point, we are just printing it. We are printing something went wrong. We can also say cannot divide by 0. Or here we can say stay in your limit. So basically what we're doing is we are just saying that the index value is only 3, then you have to stay in a limit. Of course, you can print any message, you can perform any operation here, but this is what I'm doing. I'm just trying to handle the exception with the help of try and catch. So we can have one try and multiple catch. To be on the safe side, we can write one more catch here, which is only for the exception. What if these two statements generate an exception which is not arithmetic, which is not array index out of bound, something else? In that case, this catch exception will handle it. If you don't mention this, and if you get an exception which is not arithmetic and not array index out of bound exception, it will again stop the execution. So safer side, always write the exception at the bottom. Okay, this is how you handle the exception, right? But then if there's an exception, only then it will throw the exception. What if you want to generate the exception? Example, let's say, I don't care if the value of j is 0 or not. Example, in this case, the value of j is 2. It will not generate the error. But if I say 4, of course, at this point also, it will not throw the error, but I want it to throw the error because I don't want my answer to be 0. So if you want to throw the error by yourself, what you can do is you can check if so we can do it here. Once you get the output and result, we can say if the result value is equal to 0, because in this case, it will be 1, right? Let's make it 5. So 4 divided by 5 will give you a quotient of 0. So if it is 0, I can throw the error by myself. What I can do is, how will you throw the error? Now to throw the error, we have to use a keyword called throw. So we can use a keyword here, throw, which will throw the error. But then how do we throw the error? I mean, we have a throw keyword, but how will you specify the exception? So the thing is, exceptions are classes. You can see this is a class, this is a class. If I go inside this, you can see this is actually a class. So if you want to throw the exception, you need to basically create the object of the exception. That's it. How do we get the object? We say new arithmetic exception. We got the object. We are throwing the object. Now who will catch it? This catch block will catch it. Let's see. Compile and run. You can see it says cannot divide by 0. Of course, we should print a different message here, but the exception was thrown. J is not 0, it's 5. But still, it is calling this is because we are throwing the exception. So yeah, that's how you can throw the exception. We have one more keyword in exceptions, which is, so let's say you have a method which is A, okay? And then this A method is calling B method. B method is calling C method, okay? And now in this C method, you got the exception. So how do we handle that? It's very simple. You can write try catch. You have that choice, right? Or what you can do is you can say, if there's any exception in C. In fact, before that, there is one more important thing. Exception can be divided into two parts, checked exceptions and unchecked exceptions. Now, what are unchecked exceptions? Unchecked exceptions are those exceptions where compiler is not focusing on. Example, if you talk about this statement here, compiler says, I don't care if j value is 0. But there are some exceptions where compiler will force you to use try catch. Example, when you talk about IO exceptions, SQL exceptions, at that point, compiler will tell you, hey, this might give you an exception, please handle it. So there are some exceptions which compiler will force you to do or force you to handle. Those are called checked exceptions. Now let's say C is throwing a IO exception. IO exception arises when you do some input-output with the file, and what if the file is not there? What if you don't have a permission? In that case, it will throw IO exception. So what you have to do is, you have two choices there. You can either use try catch, or you can say, hey, C throws exception. What you're doing is, okay, mind you, that's not throw, that's throws, okay? Now what we're doing is we are saying C is not going to handle it. C is just ducking the exception. Now question arises, who will handle it then? Who is calling C? It's B. It's B's responsibility to handle it or duck it. So even B can say try catch, or B can say throws exception. And now who will handle the exception? It's A, because A is calling B. So that's how you can throw the exception to the method which is calling it. Okay, so we can use throws keyword there. So we have try catch keyword, we have throws, and then we have throw as well. In fact, there's one more thing which is called a finally block. So let's say if you want to execute something irrespective if you got the exception or not got the exception. Because see, this statement here will be executed only when there is no problem in the above line. Catch block will be executed only when there's an exception. So let's say you want to do something where everything is normal or you got the exception. In that case, you can create a finally block. Now in the finally block, if you do something, example, if I say buy here, instead of doing buy here, so what you're doing here is finally block will be executed irrespective of you got the exception or not. In both the cases, it will execute the finally block. So what's the main use case of finally block? Let's say if you open a file, if you open a database connection, or if you're trying to connect with a network, those are resources. Every time you open the file, it is your responsibility to close it. Every time you open database connection, it is your responsibility to close it. Where you will close it? In the try block. If you close the connection in try block, what if something goes wrong here? It will not be closed. If you write the close statement in the catch block, it will close only when there's an exception. I want it to be closed anyway. So maybe you can write both in try and in catch, but don't you think we are repeating the statements? So we can put them in finally block. So finally block will be executed irrespective of you got the exception or not. And that's all about exception handling in Java. In this video, we'll talk about collection API. Now, if you remember, we have talked about arrays, right? Now, array has a fixed size. So whatever size you mention, it can be with the static values or it can be using a new keyword. So when you say new int array, you have to mention size of it, right? And we do the same thing for the students as well. The students array, remember? Now, the thing is, if you want to make it flexible, now in Java, they have introduced this concept a bit later, not in the primary language. And they have introduced in the second version of Java, which is collection API. Now, collection API is a concept, and in that as well, a lot of people get confused with this collection word. So collection with small c is a concept, collection with capital C is actually interface, okay? So don't get confused between these two. So when I say something is there in the collection API, I'm talking about the concept. Okay, cool. So now let's create an array which is of dynamic size. The way you do that is by using a class called ArrayList. So we can create an array list which works similar to array because we can have multiple values. The thing is, it is expandable and shrinkable, of course. It's dynamic. The thing is, this particular class belongs to a package. Remember, we have talked about package. In the same way, in Java, we have a lot of different packages which you can use. And by default, all the classes which we have used till now, we never imported any package, right? It's because all these classes which we have used, like system, string, they all belong to a package called java.lang. And by default, every file will have a java.lang imported by default. But if you want to import any other package which is not java.lang, you need to mention that. Example, in this case, I'm using ArrayList. So you can see on top, we have to import this ArrayList. It belongs to our package java.util.ArrayList. So ArrayList is the class here. And this is the package. Okay, once you got the ArrayList, I can simply create a nums. Let's say I want to create a nums array. I can, and then I have to create the object of it. And this is how we do it, right? It's very straightforward. Now, with this array list, which is dynamic array basically, you can add values. Now, it's not the same way we do it with the help of index value. What you do here is you say nums dot. Of course, you can use index. But then if you want to add values, you can simply use this method called add, whatever values you want to add. So I can say I want to add 4. Okay, so that's my first element. And I can just reuse this code, copy. So you can see I'm adding 4 values here. And let's say the value is 5, the value is 9. And the value is 1. Now, this is how you basically create an array. Now, again, why you are getting this line here, we'll discuss that later, but we have added the values. And now, if I want to print this, normally we can't actually print array, but we can print array list. So I can print nums as it is, and you can see it will print all the values. So compile, ignore the warning as of now. We are not concerned about warnings, right? So let's run this code and you can see we got all the values. We got 4, 5, 9, 1. Now the thing is, this particular array list is a class, right? Which can hold values. And yes, it also provides you index value. Example, if you want to fetch a particular element, so you can say nums dot, you can use a method called get. And in this get, you can see you can pass the index value. So we have an add method, we have a get method. So let's say I want to specify 2 here. So 2 means the third element. So third element here is 9. So it should print 9 first. Compile and run. You can see we got 9. So you can specify what value you want to fetch, or you can fetch all the values. Now, let's talk about this, why we are getting some errors here. The thing is, initially when collection API came into existence, this was a correct syntax. But they realized one issue with this. When you say we are creating an array list with the name nums, we are expecting it will only have numbers. If you go back to our array, we specify the type of the elements, right? Integer, string, or student. Here we have not mentioned any type. So what type of values we have? So by default, all these values are of object type. And that's why if I say nums.add, and if I try to add a string here, even that will work. Even string works. You can say there's no problem here. And if I compile this code and run, you can see we have this array list where string is also allowed. And it looks like a good feature, right? It looks like a feature, but it's a bug basically. The problem is if you're performing an operation on numbers and suddenly you see a string there, it will give you an issue. So it's always better to specify what type of elements you're working with. Now, how do you specify the type here? So they have also introduced something called generics. Now, using generics, you can specify the type of the values you're working with. So here, array list is working with a type. Example, if I go for the implementation of array list, you will see it's a class. It was introduced in 1.2, the second version of Java. And then it says array list, and you can see there's a angular bracket and E. That's actually generics. You specify the type here. And the beauty is, whatever type you mention with E can be anything. It can be object type, it can be integer class. Yeah, that is integer class as well, which represents a class representation of the primitive type. It can be a string, it can be any custom type, your own class, let's say student class. So what we can do here is, we can specify the type. So whenever you work with this, you can say, hey, I'm working with integers. On the right side as well, you have to mention integer on both the side basically. And now you can see there is no yellow warnings. And also, we got an error here. It says, you cannot add a string in the integer array list. Okay, now we know we can solve this problem at the compile time itself. Let's not get these errors at runtime, right? We have talked about exceptions, so let's avoid that. Now, again, if you mention integer here, this is actually optional. If you wish, you can mention integer, or you can simply mention angular bracket, empty angular bracket, and it will pick up the type from here. Even that works. So you can print all the values, or if you want to print one by one value, you can do that. You can use the normal for loop as well, or you can use enhanced for loop. So let me use enhanced for loop here. I will say int n equal to num, colon num, same as arrays which we have worked with. And let's say n, and let's not print all the values. So now if I work with this, if I compile and run, you can see we got all the values. Okay, so we can print all the values one by one. Now, one thing to remember, if I go back to array list, if you can see array list is a class, it implements an interface called list. Okay, so that means we can actually, instead of specifying array list, we can also mention list here. And it's better to, to specify the interface or superclass type to mention something. And okay, we have to import this package as well. So let's say import list, and you can see list also belongs to util. Or if you go to list here, example, if I jump on list, it extends collection. So collection is the interface here. So if I go to collection, you can see it's an interface. Now the beauty is the collection interface is actually implemented by multiple classes. One of it we have seen, which is array list. So array list is the implementation of collection, right? And remember we have worked with an example of desktop, laptop, and then we said, hey, instead of talking about desktop, laptop, we should talk about computer, which is generic to any computing. In the same way, when you want to have multiple values, your collection API provides you array list, which is a list basically, which supports index values. There is one more type which we'll see now, which is set. Okay, and the beauty is set also extends collection. So both are of the same type. Now let me show you set here as well. Of course, with this list, you can perform some more operation if you want. You can say nums dot, there are so many methods to work with. You can say add, you can specify, you can clear your collection. Yeah, you can remove the values. So we have a remove method there. And try this out. You can also sort your array, you can sort your list as well, even that works. You can convert array list into array as well with the help of toArray. So it provides a lot of different features which you can try it out. But point to remember is list extends collection. Now, instead of using list here, let me try using set. So what I will do is I will just remove this part and let's use set. Now we can say set, or we can say has set, that's a class we have to use, has set. And we can specify nums, again, equal to new hash set. Now the difference between list and has set is, in the has set, basically you can only have unique values. Okay, let me reiterate. in hash set, you can only have unique values. Example, if I say nums dot, if I say add, I want to add a value which is 4. And then I will just copy this code, paste, paste, paste. And ignore this E here. E simply means element which is given by VS Code. I'm not specifying this E here. But let's say if I add value which is 4, 5, 6, and 4. Now if you can see, I'm adding 4, 5, 6, and 4. And the number 4 is actually repeated. Now if I try to print this code, if I try to print one by one value, you can see we only got 4, 5, 6. Okay, that means it only supports unique values. So set is unique values. Okay, let me do one more thing. Let me say this is 6 and this is 2. Let's see the output. I'm just curious to see if I change the value, what happens. If you can see, when I change the value, it says 2, 4, 6. Okay, that's weird. If I say 65 and 24, let's see what happens. Compile and run. You can see it says 65, 4, and 24. You might be thinking with this output, hey, is it sorted? No. The thing is, set will not follow any sequence. So whenever you add value in the set, it will not follow the sequence. It will not even have the index value. Example, if I say nums dot, you can see there is no method to get a particular element. There is no get method here, if you can see. Okay, so that's the thing about set. You cannot get the value. So you can iterate between the elements and you can fetch the value. That's one choice, but there's no index value to it. How do you differentiate between list and set? So why I'm talking about set here instead of hash set is because if you go to hash set, which is a class, implements a set interface. And this set interface extends collection. So basically list and set, they both are collection. That's the common thing. They both can support values. That's a common thing. The difference is list can have repeated values, set cannot have repeated values. List has index, set does not have an index value or index to work with. And list maintains the order, set don't. Okay, cool. So that's the difference between list and set. The other part we can do here is, what if you, see when you talk about list, it supports index value, right? So for every element, it can be a string, it can be an object, it will have an index value, right? 0, 1, 2. But sometimes you want to have a key and a value pair. So how do we achieve key value pair in Java? For that, we have something called map. So map supports key and a value. In that case, we have to specify two generic type, a key type and a value type. So let's say for me, the key type is integer and the value type is string. Okay, and then I can say this is, let's say map itself and equal to new. Now map is an interface. If you go to map, map is basically an interface. So the class which implements map is called hashMap. And you can specify, yeah, so that's a map. Now, how do you add element here? So we don't have an add method in map, we have a put method. So we can use put and we can specify the any integer value, let's say 101. So let's say we have a course number and course name. So let's say the course number is 101, course name is Java. And then we can just say, copy this. So we can say this is 102, this is 103, this is 104. And let's say the course name is JavaScript, the course name is blockchain, and the course name is lesser data science. So we have all these courses, right? And now, so what we are doing is we have a different index value. You might be saying, hey, we can also use index value here, right? Anyway, you're using integers. The thing is, this integer can change. You can also have string, a key of type string, and a value of type string. Or maybe you can have a string and integer, like a phone book. Every name will have a number, phone number, right? So we can have that combination as well. But the only thing is, this key has to be unique. Okay, before we talk about unique, what I will do is I will try to print this map and let's see what happens. So if I clear this and compile, run, and you can see it is printing the map itself. But what happens when you repeat index value? Let's say I'm saying 102, not the index value, but the key. Both of them are 102. And let me repeat the course name as well. Let's say this one here is Java. So we have Java 2 times. We have JavaScript and DS. So we are repeating in the values and we are repeating in the key value as well. So let's see what happens. If I compile this and run, you can see we got 101 Java, we got 102 DS, we got 103 Java again. Okay, 103, 101 have the same value. But if you look at 102, it was supposed to be JS and now it's DS. It's because the keys are basically set. It should be unique. And the values are basically list, which can repeat. Okay, and that's why we are using hashMap. Internally, the keys supports set. Okay, so that's one thing you have to remember. And so that's how you can use map basically here. Now this all comes under collection API. And there is one more thing which is generic. So you can specify the type here. Of course, you can create your own generic type if you want, but there are a lot of classes which support generics. Example, map. If you go to map support generics by saying k and v, key and a value. Last time we have seen E, right? So we can specify any character there. It's just that it should be meaningful. Example, E means element, K means key, V means value. For the others, when they read your code, it should be logical. Okay, that's how we can implement collection API in Java. In this video, we'll talk about threads. See, the thing is, when you build an application, everything goes in sequence. Okay, so example, if you call a particular method, and if that method calls some other method, everything goes in a sequence. The thing is, you can't actually execute two methods at the same time. And sometimes you have this requirement where you have, let's say, multiple methods and you want to execute at the same time. Imagine playing a game. In a game, of course, you have multiple entities, right? So we have players, we have cars, we have animation, and everything is happening at the same time, right? How it is possible? So what they're doing is they have different entities here, they have different methods, and they are trying to run that at the same time. Now, I'm not saying it will run at the same time on your CPU, but the entire application or the game is trying to run at the same time. So how do we achieve that in Java? So what I will do is, to explain that, I will use a very simple example since we want to work with multiple methods. So let's say we have a class A here and we have a class B here, just to make it very simple. And in this class A and class B, I have a method which is public void show. So this show prints something, and the same thing I will do in the B as well. But what I will do in show is I want to print hi. Okay. Again, just to make it very simple, we are going for a very simple class name, very simple method name, and very simple example. But of course, you can make it complex as you want or whatever your requirement is. So here, let's say I'm printing hi, but I'm not printing hi once. I'm printing hi multiple times. So what you can do is you can use a loop here. You can say int I is equal to 1. And I want to print this hi, let's say 5 times. So I will just put that into a loop. And then I want the same process to happen in the class B as well. Okay, let's go for class B here. Okay, so how do we do it here? So let's say here I want to print hello. So I just want to demonstrate that both these methods are doing two different things. And I just want them to happen at the same time. The problem here is when you try to call these methods, example, if I create object of A here. So if I say A obj1 is equal to new A, and if I try to say B obj2 is equal to new B, so we got two objects of two classes. And then I want to start these methods. I want to call show of A and I want to call show of B. Now what I want is I want them to run in parallel. But unfortunately, when you try to run this code and if you try to print, you can see it is printing in sequence. It is printing all hi and all hello. Why it is happening? See, the thing is, by default in Java, everything runs with the help of threads. Okay, remember when we talked about exceptions? And if you have observed that correctly, let me show you. Let me create one exception here to show you what happens. Let's say I'm saying int I is equal to 7 divided by 0, and we know that it will create an exception. I want to see what exception it throws. So if I will compile this code and run, you can see it has given the exception. It is not printing this too because we are not handling it. And if you see, it says exception in thread main. There's a word thread here. So by default in your code, you have one thread. So all these things are getting executed because of that thread. Now, if you want to imagine thread, you can imagine thread as the smallest unit of a process, right? So whatever you execute, example, even if you go for your, let's say if you're using Windows, if you go to your task manager, you can see in the process tab, there are a number of threads running. So all the application, example, if I open my activity monitor here, so you can see in the CPU tab, I have all this application running now. And if you see that it is this amount of CPU they are covering here or amount of CPU usage. But if you go forward, there are threads here. So this particular application, let's say kernel, or if you talk about Zoom, which is very famous, it is consuming 249 threads. So Zoom is trying to do multiple things at the same time. So they have used 247 threads. Whatever you do in your application or in your code is running with the help of thread. So even when you run this code, a thread is running this code, okay? And that thread by default is a main thread. So the sequence is, if I remove this exception from here, the sequence of execution is, your main starts, right? This is your main thread. It starts and then it goes to create this two object. It will create this object, it will create this object, objects are done. And then it will call show method. The moment you call this show of A, the pointer, the thread will jump to the A class and it will execute this show method. It will complete the entire execution of show. Then it will go back to main on line number 30 again. And then it will call this show of B. Again, the main thread goes to class B to call the show method. And then this will be executed. So that means with only one thread, you can only do things in sequence, right? What if you want to make them parallel? So in that case, what you can do is instead of using the main thread, of course, it's there. Apart from this main thread, if you can create two more threads, one for A, one for B, and let them work in parallel. The way you can do that is by using a very simple thing. In Java, there's an inbuilt class called thread. You just have to extend the thread. That's it. Your job is done now. And the same thing you have to do for the class B as well. And of course, I know you'll be thinking it's not that simple. Okay, so we have a few more steps to go. So we have to first of all make your class thread. The second thing is the method name should be run. It should not be show. If you want to work with thread, you have to say run. Of course, if you have a show, then we have to create a new run method which will call show. Okay, but run is needed. So you have to make sure that either you change your method name to run or create a run method using which you can call show. Cool. And now what I will do is I will, instead of calling show, I have to call run and I have to call run. Okay, let's try this. Let's see if that works. And I will say compile and run. Oh, it is still running in sequence. So the thing is, we are saying that once the main thread starts, I want to create two different threads, right? But unfortunately, when you call run, it will not be happening. Ultimately, still, your main thread is executing both the runs. Oh, so the new thread is not getting created, right? So to do that, we have to actually say start. Instead of calling run, we have to call a start method. Now, both these methods, run and start, they are actually there inside the thread class. So if I jump to thread class, you can see that's a class and it has multiple methods. And if you scroll down, okay, let's search. So we got, okay, so you can see we have a run method, which is defined here. So this is a run method and you also have a start method. So what this start method does is it basically creates a new thread for you and it calls the run method automatically. So basically when you call start, it will call run automatically. So it will create a new thread, okay? So that's a process. It will create a new thread, then it will call the run method. And by doing those changes, let's see if this works. You can say compile and you have to say run. Okay. Now I know it is looking in sequence, but let's try one more time. Let's run this. Let's run this. Or what I will do is I will just increase the size or the iteration from 5 to 50. Compile, run. Oh, can you see that? Something is happening in parallel. Okay, so you can see we are getting all the highs here. Then we got two hellos. Then we got all the highs. See, the thing is, there are two threads which are running. The only problem is when in your system, basically, you'll be having a scheduler. Now, this scheduler says, hey, which thread to run? So let's say if the first thread, which is the thread A, reaches to the scheduler by saying, hey, I want to execute. So your scheduler will say, okay, I will give you few seconds or I will give you some few microseconds or milliseconds and you have to execute in that. Now, in that few milliseconds, it is executing this number of highs. When B thread goes there by saying, hey, I want to execute, it will say, okay, you have this number of milliseconds you have to execute. In those milliseconds, it was able to execute only 2. And then high. So there's a time sharing between these two threads. You can control this by doing certain things, but at least things are happening in parallel, right? There are multiple methods in threads. Example, let's say, after printing every high, let's take a small pause so that the second thread can run. So if you want to take a small pause, if you want your thread to sleep, you can say thread.sleep and you can specify the number of milliseconds you want it to sleep. Let's say, okay, sleep for 10 milliseconds. The only thing is, this is a checked exception. Remember when we talked about exceptions? So this is checked, which means your compiler is forcing you to use try catch. So what I can do is I can put this try catch here. And of course I can use IDE to do that. I will say surround with try catch. Okay. And the same thing, I can do it inside this method, which is run of B class. And now if you try to observe, if I compile this code and run, you can see it is printing hi, hello in sequence now. So after printing hi, we are saying sleep for 10 milliseconds. At that point, hello is printing. The only thing is before you print hi, you can see we have one more hello here. So again, it all depends upon your scheduler, how it is sharing the time. It may happen that both the threads will reach the scheduler at the same time. Now, scheduler can decide which one to execute. And that is what is happening here. Unfortunately, you cannot control scheduler. You can suggest, you can set some threads priority. So you can say, hey, I want to give obj1 the first priority. So you can say set priority, and you can say this is the highest priority. So if you go to set priority, you can see, you can set the priority to from 1 to 10. 1 is the least and 10 is the highest. Or you can also use constant here. So you can say thread dot max priority. Even that works. So you can see max priority is 10. So you can set values or you can use constants. And by doing this, again, you are suggesting to your scheduler that, hey, this thread is more important. But again, it depends upon scheduler how it works. So you basically can't control it. Still, if you after doing that, you can see it is printing hello in between somewhere. Maybe, I'm not sure what is happening behind the scene. I can't get into my computer, right? But at least you know something is running in parallel. In games as well, sometimes you can see there's a glitch, right? Maybe your car is running ahead of you sometime. So that's the thread synchronization problem. Okay, so this is how you create a thread, right? There are multiple ways of creating thread. In fact, 2 ways. One is extending the thread. The only problem is when you use thread here, you can't extend any other class, okay? Because Java does not support multiple inheritance. So what you can do is, instead of extending the thread, you can implement runnable here. And most of the time you will see this syntax. So instead of thread, you can say implement runnable. The only change you have to make is when you say start, you can see now these methods are not available. Even start is not available. It's because the runnable is an interface. And the only method in runnable is run. Okay, there is no start method. So what you have to do is you have to take help of thread here. So create a thread object by yourself. So 2 threads, right? Because we want to create 2 threads. I will say copy and paste. I will say this is T2. So we got 2 threads, right? And your A and B are not threads anymore. They are just a runnable implementation. They are not threads. And when you say T1, T2, you just have to say T1.start and T2.start. The only problem is, how do you link T1 with obj? Because when I say T1.start, I want it to call obj1.run. In that case, in the bracket here, you can pass obj1, and here you can pass obj2. So now when you say T1.start, it will basically call obj.run, okay? Because thread class or thread constructor takes a runnable interface, and this obj1 is actually a runnable implementation, and that's how it works. So you have 2 ways. You can either use thread class or you can use a runnable interface. There are multiple concepts in threads. We can use join. Let's say you have these 2 threads, T1 and T2, they are running now, and the main is sitting idle. So let's say if you execute something here, let's say I will say buy. Now what will happen is, if I compile this code and run, you can see we were expecting it will print buy at the end of printing hi, hello. But if you see, buy got printed here itself. It's because hi, hello is printed by T1 and T2, 2 threads. What main is doing? Main is doing nothing, right? Main says, okay, I will go ahead, I will print buy. So maybe at this point, you can ask your main to wait for both the threads to join. So you can say T1.join and T2.join. So by doing this, what you're doing is you are asking your main thread to wait, let them complete their work. And then once they complete their work, they will join back and then you can continue with your work. So the only thing is we have to surround this with try catch, and that's what we have done here. In fact, both the threads done. And now if you try to compile this and run, you can see it will print buy at the end because the main thread is waiting. So apart from this, we have some more methods. We have wait, we have sleep. You can try those. In fact, we have used sleep. Try this out, and that's how thread works in Java.